Alright guys, so here it is. We're gonna try to wrap up lesson 9.1, which is on the square roots number, taking the square roots of a number. And then we're gonna transition to 9.2. And 9.2 is on the Pythagorean theorems, is to solve for the missing side of a right triangle. Again, we are talking about a right triangle only, okay? Right triangle only. So we're only going to use this to solve for the missing side of a right triangle. So one of the side will be missing. So we have to be able to solve for the sides of the right triangle. Again, we're talking about right triangle. Okay, so before we talk about that, let's do a quick wrap up on how to simplify the square root. And again, the key term here is to simplify. Okay, we're not evaluating, we're not estimating. Okay, we are simplifying. Now, it's easy to simplify the square root of a perfect square number. So I gave you guys a list of perfect square numbers, such as, let's say the square root of 1 is 1. Okay, that's a perfect square. Square root of 2 is not a perfect square. And I think last time we guesstimated or we estimated, and we also used a calculator, we can say it's about 1.41. And then we move on, we say square root of 4. Square root of 4 is 2. And then square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. And we went all the way up to the square root of, it was the square root of 400, which is 20. So 20 times 20, or 20 squared, is 400. So some of these numbers, we recognize them. We have a list of the perfect square numbers. Okay, again, it is perfect square numbers. Now, what if we have a number that is not a perfect square, and the instruction is asking us to simplify it? So let me give you a quick example. So let's say the square root of 12. How do we simplify the square root of 12? Now, don't get me wrong. I know that the square root of 9 is 3. Okay, and then the square root of 16 is 4. So I can say that square root of 12 is going to be somewhere between 3 and 4. It's going to be between 3 and 4, right? And I know that from square root of 9 to the square root of 12 is 3 numbers. You add 3 to get to 12. And then from the square root of 12 to the square root of 16, you add 4 to get to 16. So I know the square root of 12 is going to be about like 3.4-ish, okay? 3.4. That's how we estimate the square root. But again, let's go back. It is not asking us to estimate, it's asking us to simplify, okay? So here is how we simplify the square root of 12. Okay, now if you remember what you guys learned from 6th and 7th grade is called the tree factoring methods. So what we can do is we can break down the square root of 12. Okay, again, the square root, not just 12, but it's the square root of 12. So the square root of 12, we can break it down to two numbers that have the square root. Okay, so here you have the square root, and here's another square root. So the mistake is you guys tend to forget the square root. Okay, so don't forget, when you break the square root of the number down, you still have the square root. So the square root of 12, okay, well, let's come up with two numbers that are the multiple of 12, or the factors of 12. What are the factors of 12? Now, you can say 12 is equal to 6 times 2. 12 is also equal to 4 times 3. Now, I can tell you right now, the best pair that you should pick is 3 and 4. And let me tell you why we should pick 3 and 4 instead of 6 and 2. So we're going to go here and we say square root of 12 is equal to square root of 4 times the square root of 3. Okay, now, let's go back. Why did I choose 4 and 3 over 6 and 2? Because 4 is a perfect square. So there it is. So when you're trying to break down, when you're trying to simplify a non-perfect square number, try to come up with a pair that one of the numbers is a perfect square. So I can say square root of 4 is a perfect square, and the square root of 4 is equal to 2, right? Because again, 2 times 2 is 4, and 4 is a perfect square. So square root of 4 equal to 2, and you're going to leave the square root of 3 alone because the square root of 3 is a non-perfect square number, and we can't do anything else to the square root of 3. Can't really break it down anymore. Matter of fact, 3 is a prime number. It's not a composite number, so you can't break it down anymore. So ladies and gentlemen, you're going to leave your answer as 2 times the square root of 3. Now down the road, you're going to have to have plus or minus, positive or negative. But right now, we're just going to focus on the positive answer, which is 2 square root of 3. Okay, so that is called the tree method. If you don't like the tree method, you can also do the horizontal method instead of the vertical method. You can say, okay, 12, same thing. 12 is the same thing with square root of 4 times the square root of 3. All right, and square root of 4 is a perfect square number. So square root of 4 is equal to 2. And all you have left is 2 times the square root of 3. So 2 times the square root of 3. So when the numbers next to each other like this, it means multiplication. 2 times the square root of 3. You can also put the parentheses around it if you want to. Okay. Or you can just write it as 2 times the square root of 3. Or without the multiplication signs, or understood as multiplying. Okay. Sounds good? All right, let's come up with another one. Let's say, how do we simplify the square root of 28? Okay. All right, so again, all this right now is kind of pretty much, you've got to dig up your multiplication table. Okay, find the two numbers that multiply together, give me 28. You can do 14 and 2. 14 times 2 is 28. Or it is better if you can start it out with the square root of 4 times the square root of 7. Okay, so we're definitely going to give you a multiplication table that make it handy for you. We'll make a copy of it. We'll give you a copy of the multiplication table from 1 to 10 so that you can use it to assist you a little bit. And hopefully after this chapter, we have a better idea of how to break down composite numbers. Again, so square root of 28 is 4 times 7. Okay, so square root of 28 is the square root of 4 times the square root of 7. And the square root of 4 again is a perfect square. So that's going to give me 2. And bring down, so 2 times the square root of 7. And that will be your final answer. Okay, let's come up with another one. Let's say, well, how about the square root of 72? Okay, it is a big number. But again, if you can see the patterns right there, that our goal is to break this down to a perfect square number, one of them a perfect square number, a pair where one of the numbers is a perfect square number. Now 72 is a big number, but matter of fact, it has more than one pair that is a perfect square. So let's try to see if we can do multiple ways to see if we end up with the same answer. So square root of 72 is the same thing with the square root of 36 times the square root of 2. Now how do I know it's 36 times 2? Well, because 36 times 2 is 72, right? 36. And you double it, it's going to give me 72. And I know 36 is a good number to pick because 36 is a perfect square. 6 times 6 is 36. So square root of 36 is going to give me 6. Okay, that's going to give me 6. And all I have to do next is bring down, I don't know why I write 3, but it is equal to 6. Right? 6 times 6 is 36. So square root of 36 is 6. And now you have 6 square root of 2. There you go. All right. Now let's try a different pair to see if we get the same answer, because I noticed that, well, the square root of 72 is the same thing with square root of 9 times the square root of 8, right? 9 times 8. 9 times 8 is 72. Okay, and then I realize, oh, cool. Square root of 9 is a perfect square. That's going to give me 3. So again, the 3 is come from the square root of 9 times the square root of 8. Okay, now here's the problem though. We're not done yet because the 8 is a composite number, and I can also continue to simplify the square root of 8 because the square root of 8 is the same thing with the square root of 4 times the square root of 2. Okay, square root of 4 times square root of 2 give me square root of 8. And don't forget, you still have a 3 there, so bring down the 3. So now it's going to become 3 times the square root of 4. And the square root of 4 is another perfect square number. The square root of 4 is 2. Alright, and then bring down the square root of 2. Okay. Please don't forget, it's the square root of 2, not 2. The square root of 2. Bring this down. Okay, and then 3 times 2, that's going to give me 6. And the square root of 2, again, we can't do anything to the square root of 2 because it's a prime number. Is 2 can be broken down any further. So I'm going to leave that as 6 times the square root of 2. And you know that you end up with the same answer that I have over here. So ladies and gentlemen, it doesn't really matter with the two numbers you try, as long as you continue to factor and continue to simplify the square root, and at the end you're going to end up with the same answer. Alright, so that is how we simplify the square root of a non-perfect square number. Simplify the square root of a non-perfect square number. And we'll do a couple more from the homework where the number can get very, very big. And at the end of the day, again, our goal is use the 3 factor and break down the number, break down the composite number, and continue to simplify the square root until we can't do it anymore. Alright, so right now I'm going to have you guys do the classwork activity on your own. Use the note that you just took from this video to assist you, and hopefully we'll be familiar with how to simplify the square root of a non-perfect square number before we move on to lesson 9.2, which is on the Pythagorean theorems.